Hello students, I am Prem Dhawan. I have been teaching chemistry for the last 33 years in one of the leading schools in Delhi. And today I'll discuss about how to attempt the chemistry question paper in CBSE. As you know, CBSE chemistry question paper is on 27th Feb. It's almost 1 month left now. So you have to prepare for the chemistry exam very carefully and give a proper time to clear your concepts and attempt more and more questions from the sample papers. As you know, there are 10 chapters in chemistry and we have a total maximum marks for chemistry paper equals to 70. So on an average, each chapter has a weightage of 7 marks. So for a student, each and every chapter is equally important. So you can't neglect any one of the chapter for CBSE exam. Next is, if you look at the structure of the question paper, there will be 33 questions this year in the chemistry question paper and there will be 5 sections. Section A has a multiple choice questions and in this section there will be 16 questions. Out of 16, 12 questions with one option correct, multiple choice questions, and 4 questions are assertion reason based question. And there will be no choice in this section. So you have to attempt all 16 questions. And you must attempt each and every question because there is no negative marking in CBSE. So there is no point leaving any question unanswered. You must write answer to each and every question in this section. Now section B is short answer type question and there will be 5 questions in this section. Each question carries 2 marks. Section C is also short answer type question. There will be 7 questions in this section. Each question carries 3 marks. And in section B and section C, you will have one internal choice. So you look at the option very carefully and then attempt the question. You see which option you know better than the other. Section D is a case study based questions and there will be 2 questions based on the paragraphs, the passage given. And each passage will be followed by 3 questions. First question 1 mark, second question 1 mark, and third question 2 marks. There will be some internal choice and you attempt the question paper, you read the passage very carefully and then attempt the question. Section E is a long answer type question. There will be 3 questions in this and each question will have an internal choice. So look at the options very carefully and then attempt. So this is about the structure of the question paper. Another important point about attempting the CBSE question paper, since there is no negative marking, you attempt each and every question. And in the reading time given by the CBSE, 15 minutes reading time, you read the question paper very carefully and plan judiciously. The questions about which you are 100% sure that I know the answer to this question, you attempt those questions first. There is no need to follow any order in the question paper. Nowhere in the CBSE question paper, in the general instructions, it's mentioned you have to follow certain order. Questions about which you are 100% sure, you attempt those questions first. And also attempt those questions first if you think I may forget the answer to this question. For example, biomolecules, D and F block elements, you attempt these questions first. And also in these 2 chapters, you have to write very less and write to the point. The next is what are the common errors faced by the students in the question paper. For example, in physical chemistry, whenever you are solving the numerical, you write the formula, substitute the values, calculate the answer along with the units. Use the correct formula. For example, in electrochemistry, when we are calculating the conductance, the molar conductance, NCERT is given this formula. Lambda is equal to kappa upon concentration, where kappa stands for the conductivity and C stands for the concentration and C stands for the concentration. But if you look at the formula and the units given, this kappa should be in Siemens meter inverse. And this concentration should be expressed in moles per cubic meter, which we rarely use. We always use moles per liter. So what happens, the students use this formula, but they put the value of the C in moles per liter. That gives the wrong answer. So to make it more accurate, to make it more meaningful, use this formula for the molar conductance: 10 raised to power 3 into kappa upon molarity, which is concentration. So in this case, in this formula, the kappa should be in Siemens centimeter inverse, and most of the time we use kappa in Siemens centimeter inverse only. And this is the molarity in moles per liter. So put the value of the molarity as it in this formula, and this 10 raised to power 3 will take care of the conversion of liter into centimeter cube. And this lambda gives the units of Siemens centimeter square mole inverse. So use this formula when you're solving the numericals on molar conductance, and don't use this formula. So this is one. Second, in electrochemistry, whenever the question comes, calculate the standard free energy change, we use this formula. The delta G degree reaction is equal to minus of NF E degree. So students know how to calculate the E degree. They know how to find the N factor. When they calculate, for example, N factor is 2, Faraday constant is 96500 into E degree, suppose it is 0.40. So this answer should be in joules per mole. They are calculating the answer in their work, but when they copy the answer, they forget to write the minus sign. Right? They only write the numbers here. They only write the number. Sometimes they forget to write the units joules per mole. Sometimes they don't write the minus sign. As it is, they lose marks. So you have to be very careful about this minus sign. So you have to be very, very careful about this minus sign, and also very careful about the units, which is joules per mole. So similarly, in chemical kinetics, when you are calculating the energy of activation, use the correct formula: 2.303 R T1 T2 upon T2 minus T1 and the log of K2 by K1. And make sure this temperature should be in Kelvin. Although difference in temperature remains same in degrees Celsius in Kelvin, but the numerator will change. It gives the different values if you are using the temperature in degrees Celsius or in Kelvin. So always use this temperature in Kelvin. This is one point. Second point, the ratio of the K2 by K1 has to be greater than 1. Otherwise, your energy of activation will become negative, which is not possible. So make sure about these two things. K2 by K1, this ratio has to be greater than 1, and temperature should always be in Kelvin. So there are some common errors in physical chemistry. And in case of inorganic chemistry like D and F block, and in the coordination compounds, whenever you're writing the reasoning questions, you write the reasoning question in a point-wise manner. Like suppose the question comes like, why is this E degree of Mn3 plus to Mn2 plus is greater than the E degree value of Fe3 plus to Fe2 plus. So you write the answer in a point-wise manner. It means this reaction is more favorable than the conversion of Fe3 plus into Fe2 plus. Now you have to give the reason why this reaction is more favorable, why manganese 3 plus has more tendency to change into Mn2 plus. Then the second point you write, this is possible, this is favorable because by the gain of one electron, manganese becomes Mn2 plus, which has a stable half-filled argon 3d5 configuration. So prefer the configuration in terms of a noble gas. Don't write the expanded configuration. Write the configuration in terms of a noble gas. Now this reaction is not favorable or less favorable because Fe3 plus already has a half-filled configuration. So by the gain of one electron, it becomes more unstable. That's why this reaction is less favorable as compared to first. So always write the answer in a point-wise manner. It should be very clear to you what are you writing in the answer. Now, in case of chemical equations of KMnO4 and the dichromate, whenever you are writing the equation, first of all you write the correct products. For example, the KMnO4 MnO4 minus, the paramagnet ion, always changes to Mn2 plus in acidic medium. So if the medium is acidic, you always write Mn2 plus on the right hand side. Right? And then you write the medium is acidic, so you should write H plus ion on the left hand side. So whenever you're writing the equation, first of all you write the correct products. So in this case, one of the product is Mn2 plus. Second, since KMnO4 is a very strong oxidizing agent, it will oxidize the ferrous to ferric, and the H plus ion gets converted into water. So first of all, the product should be correct, and then the balancing comes. So if the products are wrong, balancing is automatically wrong. Another point, in the case of dichromate, dichromate always changes to chromium 3 plus, because these are the only oxidation state which exists for chromium, either plus 3, which is more stable than the plus 6 in dichromate, because chromium 3 plus has a half-filled T2G3 configuration. So in the reactions of dichromate, you always write chromium 3 plus as one of the product. And dichromate exists only in acidic medium, right? In basic medium, it gets converted into chromate. So careful about these small points. Now, when it comes to organic chemistry, you have to be very careful about the reagents, conditions, reaction conditions. For example, the role of aqueous alkali in organic chemistry is to replace the X minus by OH minus. So whenever you see there is an aqueous alkali, it will replace the X minus by OH minus. And whenever you have a hot and alcoholic potash or hot and alcoholic alkali, it may be KOH, maybe NaOH, then it results in the elimination of HX. For example, if we are using this, I'll give you two examples, CH3CH2Cl, we are using aqueous alkali, aqueous KOH, then it replaces the Cl by OH. Now this is called nucleophilic substitution. But the same chloroethane, when being treated with hot and alcoholic potash or alcoholic KOH, it results in the formation of alkene. This is called elimination, this is called dehydrohalogenation. Now we take one more example like this, CH3 COCl. Now if you are reacting this compound with aqueous KOH, it replaces the chlorine by OH. But since the medium is alkaline, this acid immediately gets neutralized by KOH to give a salt. But it's a nucleophilic substitution. But the same CH3COCl, when being treated with hot and alcoholic KOH, it results in the loss of HCl to form CH2 double bond C double bond O. So we have eliminated the chlorine from this carbon and H from this CH3 carbon. So in organic chemistry, you have to be very careful about the conditions used. Temperature. For example, the diazonium salt exists only in ice cold solution, 0 to 4 degrees Celsius or maybe 5 degrees Celsius. But slightly if you heat the diazonium salt, it will decompose to give the phenol. For example, this is aniline. When this aniline is being treated with NaNO2 and hydrochloric acid, you have to mention the temperature 0 to 4 degrees Celsius, or you write ice cold solution. Only then this diazonium salt is formed and exists and is stable. Right? If you are heating this, it will decompose to give phenol. So you have to be very careful about the conditions, this ice cold conditions, 0 to 4 degrees Celsius. Now, another important type of questions in organic chemistry is the test to distinguish the pair of organic compound. So, whenever you have to distinguish the pair of organic compound, you always give a test where you observe something, like some smell is there, some precipitation is there, some color change is there. These type of tests you have to give. And whenever you are writing the answer, write only one test about which you are 100% sure. Even if you know more than one test, or you write one only. For example, if you are given this test to distinguish between the ethanol and ethanoic acid. So we have number of tests to distinguish this pair of organic compound, and always write in a tabular form so that it is easier for the examiner to decide 1 or 0. So your answer should be very crystal clear. So you write the test, then write the name of the test. Like in this case, since one of the compound is aldehyde, we can use tolerance test, we can use Fehling solution test. And other compound is carboxylic acid, we can also use sodium hydrogen carbonate test, we can use esterification, but you write only one out of all these. You write the name of the test. For example, I am using the tolerance reagent test. Then you write the reagent used in this. So we use ammonium silver nitrate. So this is tolerance reagent. And then we warm the solution. And this aldehyde, the ethanol, acid aldehyde, it gives a silver mirror. So the one which is giving you some observation, you have to write the observation. And the one which is giving negative test, you can write negative. So you can write negative here. But the compound which is giving a positive observation, you can't write simply positive test. No, you have to write the observation. No chemical equations are required in these type of questions. So you have to be very, very careful. So read the question very carefully. What you have to write in the answer. Sometimes we give a question, identify the compound, write the structure only. So write the structure only. When the question comes, write the structure and IUPAC name, you write this is structure, this is IUPAC name. Right? I'll write the answer in the same order. So if the question comes, write the structure first. Then write IUPAC name, then write IUPAC name. Sometimes to write the structure becomes difficult. For example, if you have a question, write the structure of the ethylene ketal of cyclobutanone. Now in this case, it's very difficult to write the structure directly. So what you have to do, you write the equation first of cyclobutanone. This is cyclobutanone with ethylene glycol. Now this is ethylene glycol. You remove this water molecule and then you write the structure. So once you know that this is the product form, and write this product as your answer. But initially it's difficult to write this structure directly looking at the question. So your answer will be this. So the structure is this. So this will be your answer final. So in this type of question, if you don't know how to write the structure initially, you write the equation, you write the product, then write that product as your final answer. So you have to be very, very careful. Also in organic chemistry question, when the question comes, explain this name reaction, write a short note on this reaction, you remember the equation of that reaction, and then you write that equation in words. And when you're writing example to support your answer, you always take a simple example. Don't give any hi-fi example, because chances of error then will be more. So the important points are, if I recapitulate the important points, So you read the question paper very carefully, attempt all questions because there is no negative marking. Each and every question you attempt, but in any order. Questions about which you are 100% sure, you attempt those questions first. And write the answer what is required in the question. Don't write anything extra. And write answer only in a point-wise manner. Like this is the structure, this is the IUPAC name. So these are the tips, these are the important points you have to follow. And I hope you will score good marks in chemistry. And if you want to see more sample papers, then you can click the link, go to our website and see how to write the answer in the question paper. All the best. Thank you very much.